Have you ever wondered how a simple idea, a little spark of curiosity, actually turns into a real, published discovery? Well, today we're pulling back the curtain on that whole process. We're going to follow the path all the way from that first what if to a piece of research that could change an entire field. So, it really all boils down to this one question, doesn't it? How does a simple idea become something we consider a scientific fact? This isn't just about people in lab coats mixing chemicals. It's a genuine quest for knowledge, a real adventure. And we're about to follow the map.
All right, so the very first stage of any big journey is just understanding the terrain. And in research, that means you've got to know what's already been discovered. You see, every single breakthrough, every amazing new idea, it's all built on the work that came before it.
And that brings us to the literature review. Think of it like this. You wouldn't set out to explore a new continent without studying all the existing maps, right? A literature review is exactly that. It makes sure you're not trying to solve a problem that's already been cracked. Or, as one source put it, reinventing the flat tire. It's a really systematic and thorough process. The whole point of that literature review is to find a research gap, basically an unanswered question or an unexplored corner of the map. And this isn't just about reading a bunch of papers. No, it's more like active detective work. You're hunting for contradictions, looking at the limitations of what other people have done, and even finding questions that other researchers have pointed out themselves. And sometimes the coolest ideas come from looking at where totally different fields connect. So where do you actually find all these maps? Well, you use research databases. These are kind of like your specialized libraries. If you're into cutting-edge engineering or hardware, you'd probably head to IEEE Explore. For the deep, theoretical computer science stuff, the ACM Digital Library is where it's at. And of course, for a good starting point on just about anything, there's Google Scholar. Knowing which tool to use is definitely half the battle. Okay, so once you've found that gap and you've done your own research, you need to turn your findings into something tangible. That something is the research paper. It's the main way new knowledge gets recorded and shared with the rest of the world. And you'll see that most scientific papers follow this really logical structure called IMRAD. It's a great storytelling framework, really. You start with the introduction, what's the problem? Then you get into methodology, what did you do? The results, what did you find out? And finally, the discussion. So what? What does it all mean? It just creates a super clear and logical story for your reader to follow. Now, to actually write the paper, you need the right tools. The two big players in this space are LaTeX and Microsoft Word. You can think of LaTeX like a powerful, specialized forge. Yeah, it's got a steep learning curve, but for technical papers with a ton of complex equations, it's just unbeatable. Word, on the other hand, is more like a versatile, easy-to-use workshop. It's super intuitive and great for most writing, but it can get a little clunky with really, really long documents. But here's something that has totally changed the game for modern researchers: version control systems, especially Git. You can forget about saving files like final paper, _v2, _updated, _reallyfinal.docs. Git is literally a time machine for your project. It tracks every single change, it makes working with other authors a breeze, and it means you never, ever lose a brilliant idea or a line of code. It's an absolutely essential tool these days. Of course, all of this is built on a really critical foundation: academic integrity. This is the researcher's code of ethics, and it's pretty simple. Give credit where credit is due. It doesn't matter if it's an idea, a sentence, a chart, or even something from your own previous work. You have to cite it properly. It's the absolute bedrock of credible science. So, your paper is written. Now comes the biggest challenge of all, the trial by fire we call peer review. This is where you send your work off to be judged, harshly but fairly, by anonymous experts in your field. It's how science keeps its standards high. Now, this whole process isn't some mysterious black box. It's a really structured system. First, an editor gives your paper a quick look. If it passes that initial screen, it gets sent out to a few anonymous reviewers. They'll read it, critique it, and then recommend a decision: accept, revise, or reject. And based on all that feedback, the editor makes the final decision. It's tough, for sure, but it's essential for making the research as strong as it can be. And just how tough is it? Well, for the top-tier computer science conferences and journals, the acceptance rate is often between just 15 and 30%. Think about that. That means for every 10 papers submitted, maybe only 2 or 3 actually get in. That number really shows you just how high the bar is to get something into the official scientific record. But I do have to warn you, there's a danger lurking out there on this journey. It's a modern trap for researchers, and it's the rise of so-called predatory journals. These are basically scam publications that care more about profit than science, and they'll charge you a lot of money for little or no actual peer review.
So, how can you spot one? You've got to look for the red flags. You get an aggressive email full of flattery that's super vague about your actual work? That's a huge red flag. A promise to peer review your paper in 48 hours? Yeah, that's impossible. A website that's full of typos? Or an editorial board with names of people who don't even know they're on it? Run away! Knowing these signs will absolutely protect your work and your reputation. Okay, you've survived peer review, you've been published. Now comes the really fun part, the final rewarding stage of the journey, sharing your discovery with the world. And that often happens with a presentation at a conference.
A good presentation follows a pretty similar story arc to the paper itself, but it's built for a live audience. You kick things off by explaining why your work is so important, you walk them through how you did it, and then you show off your results. That's always the star of the show. You wrap it all up by explaining what it means and, importantly, what could happen next. And to create your slides, you've again got some great choices. PowerPoint gives you just unmatched professional control. It's perfect for those really data-heavy technical talks. Canva, on the other hand, is incredibly easy to use, and it's amazing for quickly making slides that are just visually stunning, with a real focus on design. But listen, whether you're writing the paper or making the slides, there is one final step you absolutely cannot skip: proofreading. This quote right here says it all. Little mistakes, typos, grammar issues, they can completely destroy the credibility of even the most brilliant research. It just screams that you don't care about the details. And this chart really shows why you need a multi-layered approach. You might catch about 60% of your own errors. Having a colleague look it over will probably catch another 25%. And then those digital grammar checkers can snag that last 15%. See? No single method is enough. You really need all three to get a truly polished professional product. So there you have it. From a simple question to a public discovery, that's the research journey. It's a path that demands rigor, creativity, and a whole lot of persistence. And you know what? It never really ends, because every answer just leads to more interesting questions, which means the only real question left is which one will you choose to explore?